So, yeah, welcome to this. If you're doing challenges, please do it quietly. That's the first one. Okay, this talk is pretty much improvised. I have a couple of slides. I don't like slides very much, so it's much more action. And the action is a bit going to be, well, I'm doing something, and I'm going to tell you what I'm doing, and hopefully you understand why I'm doing it, and maybe it's helpful for you. The topic is Tracewrangling, preparing food for the shark obviously being wire shark, and Tracewrangling. Tracewrangler is a tool that I wrote to work on trace files, capture files, DCAPs, DKBDs, whatever you have. My name is Jasper Bongertz. I'm working at Airbus, but not the commercial airlines, but the defense and space things, which means fighter planes and satellite construction, which is kind of a military thing. So we're doing cybersecurity, me and my colleagues, and that means we're reading capture files every once in a while and doing security when we're not. Okay, so Tracewrangler in general, it can do a lot of things. I think even Laura starts to mention it now. What it's not is, it's not an animation toolkit. It's a toolkit that can also anonymize stuff. So it's much more than just that. Most people think it's doing anonymization, but I'm using it for a ton of things. So Microsoft keeps monitoring here. Basically, the first thing it ever did was sanitization or anonymization, meaning replacing IP addresses, MAC addresses, port numbers, cutting away payloads that you don't want to see somebody to see. So that was the first thing it could do, actually. Then the next thing I added was merging files. You probably have used MergeCap at some point, but MergeCap has a little problem right now that if you're merging capture files with multiple network cards in the file, which PKG can do, it will stumble and fall at some point if you're not lucky. And I added merging capture files to Tracewrangler to be able to merge my files because I needed that. So a lot of things that is in here is because I needed it. And if you happen to find it useful too, you're lucky. If you have something that you need that's not in there, you can always ask me and try to put it in. That is, for example, the editing of packets. Now, editing packets here means it's not going to change times and packet lengths and stuff like this. But stuff like you have an encapsulated packet that you need to be reduced to the upper layers that are in there, and I'm going to show you examples of what it's doing. I had somebody, I think 2 years ago, coming up like, I have a capture file that is taken on a Juniper device, and Juniper is having like a little layer in front of the actual packet. So in each packet you have this Juniper layer, and that means no tool that doesn't know how that layer works is able to read the capture file. And I have a function in there where you can tell Tracewrangler, please remove all the Juniper layers, I don't want them. Okay? And it's not against Juniper, it's just you have tools that don't, well, they can't work with it. And there are also tools that don't like MPLS streams or GPT-U, which is tunneling over GPRS. I have a very funny trace I'm going to show you where you have like 50 layers on top of each other, like 2 internet layers, MPLS streams, GTPU, and it's like this high, and you probably only want the last Ethernet IP TCP thing, and it can do that. And I will show you. Extracting packets into new files. This is probably something everybody has done before, like filtering and then, well, in former times it was save as, now it's not save as anymore, now it's extract specified packets in Wireshark. The things that Tracewrangler can do is a little more complicated because you can tell Tracewrangler like, here's a set of 100 files, here's a small trace file with single frames in there, and I need all conversation where those frames appear in. So I want all the conversation in single files, please give it to me. And it will do that. It will scan through the whole file set and extract the conversations to each single frame that you gave it. You can also use Node alert signatures and results to parse that out, which is something I need. Then the other thing, capture file name and timestamp adjustment, I will show it to you. This is basically just the agenda that we're going to do or go through as long as I have time. If I run out of time, I can always show it to you in the reef or during the conference. Endpoint and conversation overview, that is like the one in Wireshark, but over all files that you have opened, or not opened, that are in the list, so you get an aggregated conversation statistics over hundreds of files if you want to. The biggest I've done so far, I think, is about 2.5 million TCP sessions in the statistics, so that's really cool. And it will also give you some additional hints about the state of the TCP conversation. It will tell you this one has a problem because the SYN didn't work at first, and you got a second SYN, and then only that SYN came back. So I hate scrolling through trace files looking for things that are strange. So if my tool can do it for me, why not? It's very simple. It's just basically a TCP state machine for the TCP session start, but it will tell you this one was rejected, or this one was half open, or this one was accepted, but only after the second SYN pack. So you can focus on that, filter on that, and find it real quick and take a look at it. Well, and the rest, basic capture, result validation, you can have it show you the PCAP-NG file structure to see if you're writing a tool that is writing PCAP-NG, the new file format everybody should use. You can verify if your tool is doing it correctly, and the problem with that is that sometimes developers actually do this, and it turns out my code is not good enough and it crashes, so I had to fix it. That's perfectly fine, just let me know and do whatever I can to fix stuff. Question? Okay, yes, stretch. All right. Okay, I think I only added this slide out of, making it easier for you to know how to get it, because Tracewrangling is a free tool if you want to use it. It's at HTTPS, www.tracewrangler.com. The HTTPS thing is because I need to make sure that you get what I sent and not some three-letter agency changing some bits on the way to you. This is why it's HTTPS. And there's also my PGP key, which it is signed with, so you can verify it, and there's MD5 hash sums, so I'm cybersecurity. I'm not taking this lightly, even though it's a simple tool, okay? So if you want to download it, you can verify that nobody messed around with it. That is something you need to do today, as you've probably seen SourceWatch is doing stuff like this, and that's not good. Okay, so I think now the demo slide is coming up. Yeah, correct. So this is a moment where all the people later downloading this will be like, damn, because it's no more on the sites, because the rest will be live. But I record it, and if it works, they can watch that. If it doesn't work, they're out of luck, but we're here, so you will see what I do. Okay. So actually, if you start Tracewrangling, it will look just like this. There's not much you can do. Actually, the file options are just adding something or exit. There's some preferences in there. You've got a couple of tools and the help. And actually, I'm really proud of the help, because I don't know if you've seen this, but I wrote a lot of stuff in there. So documenting is not my strong suit, but I try to do it as good as I can, so there's a lot in here. So I took a lot of time to document it for you. So if you get stuck, you can look in there, or otherwise just ask me. Okay, so the way to go here is to add a file, because it's processing file basically. Let's say you have something like this HTTP example. You just drag and drop it on the form, or you could also do a file add and then find it. Doesn't matter. Yeah.
Do you have any plans to release a network?
Okay, the question is, like always, am I planning to release a Mac version? I have heard that since the beginning of time, and I would like to explain myself right away, so that you don't have to wonder. I'm a network analyst, which means I'm not a programmer. I'm somebody who reads packets for fun every day, like others read the newspaper. I'm not writing code like a pro, like the Wireshark devs do. So the question was, do I write this in something that I could port to other platforms, like in C, C++, or whatever? Or do I use the one language that I happen to know, which is Delphi, which is Windows only? And the question was, okay, do I take 3 years to learn how to do that? Or do I use what I have and use the 3 years to get here?
So use VM.
I use the 3 years. So use a VM, or what you can also do, at least on Linux, I've been told that it runs fine online.
Yeah,
So,
will it run in line?
huh?
Will it run in line?
Yeah, it will.
Option number 3.
Option number 3.
And don't show this message again.
Right, yeah, I was too confused to read it. You know, I don't like much text on my slides, and I don't like much text in my option boxes. Alright, so there's no Mac version. I could do a Mac version if I rewrite all of the GUI code, because the Delphi cross-compiler could do that. But I have to write it in a different framework, and half of the code in here, and it is about right now, I think, 180,000 lines of code. I wish to have to rewrite half of it, and there's some listing components that I don't have for the new framework, which means right now I can't. And maybe I will at some point, because the Mac users still keep throwing apples at me sometimes. Okay. Good. So now we have the tracer in here, and the rows in the back probably can see this, but it just tells you the number, the name, the size in kilobytes or megabytes or whatever, the file type, the first frame time. This is actually the timestamp of the first frame in the file. So whenever you add a file, Tracewrangling will open it, get the timestamp of the first frame, and use that to sort the list. So it doesn't matter what the file name is. The file name is always sorted by frame timestamp of the first frame in the file. So if you mess up your file naming, it will still get the correct order in time. Yeah, so if you have like 10 files that are captured after each other, and you fool up when naming them, it doesn't matter, because it will just arrange them by frame time. Then there's the duration, the number of frames in there, and the status is no task assigned, because we don't have any task yet. So the next step here would be to add a task. Okay? So let's say we want to anonymize this sample, and let's take a look at this. So it looks like this. It's just a simple HTTP GET on some IP addresses. I think you can all tell that this is a private one, this is a public one. There's some ports in here. So if I want to sanitize this, anonymize this, I can do that. It's really simple. I add a anonymization task, or since I'm lazy now, and that is just something I never use, I go here and say instant anonymization task, and then you get the dialog where you can set all the options of what you want to do. And this is actually something I work on every once in a while and improve it and put more stuff in there. It's come quite away from the first version of 2 years ago. What you can do, for example, is you can remove the payload, or remove all unknown layers, which means everything that Tracewrangling doesn't know what it is, which potentially means it's exposing sensitive data. If it keeps it, it will remove. So it will cut the payloads that it doesn't know what it is and just drop them from the frame. But it will keep the frame size intact, so that when you do analysis, it will still be the correct length. Now, it's not padding it. There's two numbers in each frame. The one that was on the wire, the length, and the captured length. And it will reduce the captured length. So Wireshark will know this packet was 1500 bytes, when now, through cutting, it is only like 100. Yeah, so every sequence TCP analysis will still work. This is something most other analyzers or sanitization tools do wrong. They cut it and they set the frame size hard-coded to the shorter version, and then your TTP expert goes like crazy because it's saying, hey, segment missing, segment missing, segment missing. This doesn't do this, okay? The new option that I added here is that you can choose to cut away bytes that it doesn't know. You could also say, well, I want to zero them. This is quite funny if you want to basically annoy people by giving them large trace files. That's sanitized, you know. If you're doing my challenge, I have a special challenge coming up in a week after this. I did something like this. The traces are quite big, and I don't want them to be smaller because it makes it harder for you to solve the challenge, actually. And it was that big when I did it, so why should you get an easier one? I could also do a replace byte with pattern, so it will write this string that you put in here as many times as necessary over the payload. So it will be like cut in the end if it's not fitting correctly, but you could put stuff in there like, this is payload that was removed, so everybody knows, looking at it, like, oh, this was sanitized. Yeah, so that helps sometimes if people are wondering why this trace looks like this. Okay, the other thing you could do, of course, is truncate after, let's say, layer 4, or 2 or 3, whatever you want. The interesting thing here is that other than edit cap will cut as a specific offset, and it will remove everything after that. But if the protocol layer is longer or shorter because of options, you cut sometimes the options off, and that makes the packet kind of broken. Tracewrangling knows exactly how long those options are, and it will cut exactly each packet after the layer. So it doesn't matter how many options are in a packet, or if the packets have different options with different sizes. It will always cut at the correct spot. If it doesn't, it's a bug, and you should let me know. You can also do this thing that EditCap does, cutting at 54. 54 is a funny number. If you're a network analyst and you know this number or you know what it means, congratulations. If you're wondering why I choose 54, well, we could have a talk at the reef. Okay? It's a very specific number. If you don't, yeah?
You just check both of them.
Yeah.
Airport cutoff or the at an offset.
I check all 3 of them right now.
Is there?
You know what happens now? It's quite funny because Tracewrangling will go and each packet it reads, it will check, is there anything I don't know? If yes, it will be removed. Then it goes and says, well, is that what I know longer than layer 4? So if it knows, for example, DHCP, you can sanitize DHCP with this. So it won't cut it away because it's known payload. It knows what it is. But if you're saying cut it after layer 4, it will still go. So it's like a second step. And the third step, again, is after doing all this, it will check if it's longer than 54 bytes, and if it is, it will cut it. So you can combine this. Yeah? Jeff, maybe you want to come to the front? Or can you hear me? No, you can't. Jeff? Can you hear? Okay. Otherwise, I do a one-on-one with you. No problem, I can do that. I have time. I'm at the reef after this, so just come over. Okay, if you choose to keep all the payload intact, which is a dangerous thing, you should not remove all of those if you're not sure that nothing in that capture file is okay to be public. Then this option becomes possible, and you can go in and replace specific strings and say, I need to replace a specific FPDN or whatever it is. And the fun thing here is that you cannot replace anything with something that is shorter or longer. Do you know why? Because if you do that, all the sequence numbers will be wrong in the following packets. So if I replace something as a string, it will be exactly the same size. If you give it a string that is longer, it will be cut. If you give it a string that is shorter, it will be padded by zeros. Yeah? And there is a counter up there on the right that tells you how much you have left. So if I'm going in saying, well, let's see what I have in that address.
On that string search, does it go across packet boundaries?
No. It goes per packet. Yeah. Reassembly I haven't implemented yet because reassembly actually is a nightmare. And that is no fun at all. And I want to be able to anonymize stuff like HTTP and FTP and everything. For that I need reassembly first, and then we can do this, but not before. I mean, if anybody wants to have a talk about anonymization, TCP payloads, I can talk to you about this for probably until you fall asleep. Because it's really hard to do, because you need to adjust all the sequence numbers and you need to shift them for every remaining packet, or every packet after the one that you're doing. You need to reassemble, you need to remember how long the packets were before you padded them and did stuff. So it's really bad. So this is why it's not easy to do. Nobody has done that as far as I know. Yes?
So I guess you don't have to allow the regulars
this is not regex right now. I could do it. I mean, if you want me to put in regex, which makes it really slow, I could do it. The size limitation will probably kill it, but I would do the regex replacement and then cut the size again or make it longer. That's not a problem. I could do regex, but regex is really slow. So the string replacement was put in for last SharkFest, and I worked a bit on this because what you can do now is, maybe that helps. You can go in here and do like snort style replacement. If you put in a, what's it called, pipe sign, you can do bytewise replacement. So this counts as 3 bytes, I think. Yeah, it says left 3. So I can replace that with new bytes. So you're not limited to string replacement, you can also do byte replacement if you need. 10, 11, 12. Stuff like this. You could also mix it with text. Now it's too long. It says here. Let's see how long answer is. No G. Sorry. Okay. So basically, with this, you can replace any kind of byte sequence if you use the pipe signs, or any kind of string, or you can combine them as well. I don't know why it's still red. That is a bug. So it should be okay now. Alright, case insensitive hashing I think is pretty clear. So this is something where I worked a bit on, and that should be helpful. So PKBG, there's a couple of things where you can sanitize PKBG stuff. Ethernet should be also clear. Usually you randomize the MAC addresses, but you can choose to leave the vendor paths intact. So if you want to preserve that the device was actually a printer or something else, you just keep the first 3 bytes and only the second 3 bytes will be randomized. By the way, all the randomization will always keep state, which means if a MAC address or any IP address is replaced by a new one, it will put that into a database and remember what it did. Like if it's seeing the same original MAC again, the same new MAC will be applied. And it goes as far as checking if the new MAC that is randomized doesn't already exist as a replacement, because otherwise you get a double. And that is not a good idea. For IP addresses, it's even worse, because for IP addresses, it's checking if there's a loopback address, if it's like a broadcast address, or if it's an existing address, or all kinds of checks are done. And this is something where I had to put a lot of work in to get this done. So, the other thing here is to recalculate the checksum. This is actually something I put in on request by Stuart, which isn't here this time because he has a baby now. Congratulations. He sent me an email like I'm not coming to SharkFest. He wanted to have the Ethernet FCS recalculated, which I couldn't do before, but now I can. So if there's FCS in a packet, which is quite rare, you need usually a hardware capture device to do this, to get them at all. It's possible to do this. And you have 2 options here. Fix all checksums means it will do the correct checksum for everything, even if it was broken before anonymization. But I mean, we're network analysts, so an error in a packet should stay an error in the sanitized one, right? Because you're trying to fix something and give it away to people that should see the same that you did. So usually the setting is keep bad checksums bad. Meaning, if it was broken before sanitization, don't fix it, keep it bad. And that's actually another interesting problem, because how do you keep a checksum bad? Well, you could just randomize it, but there are chances that you hit the correct one. So what do? Well, what I do is I calculate the correct one and add 1, so it's bad in any case. And you can also tell that it was calculated, because if it's Wireshark will tell you it should be this, and if you see it's a difference of 1, you know, oh, Tracewrangling did that. Okay, then the other things here are VLANs. You can remove VLAN tags, some of them, all of them, whatever you want. You can change the VLAN tag number if you want to. This is basically also like editing a packet. Then there's tunneling. I don't know if you know the IDEA protocol that is used by Success for their IPv6 tunneling. I'm using it, and they have my user ID and password in the layer, so I wrote a small code to replace it. Nobody needs this except me, but it's my tool, so I can afford it. So the more interesting stuff probably is IPv4. What you can do here is replace IPs by a list. So you can go in there and say, well, I want to replace, let's see, what kind of IP addresses did I have? Let's say 192, 168, 124, 100. Unzoom, this is complicated. So, 192, 168, it stays red as long as it's not a valid IP address. Now it's valid. And let's say I'm doing this like 172.1.20.11, something like this. I can do add a new and add another one if I want to. But if you're lazy like I am, and I'm really lazy guy, I put in an option like this, lookup, and it will tell you all the IPs it found in the trace. So you can just double click and say I want to replace it with 10.0010. Done. It's much faster. You can also add multiple if you want to. And the other thing is you can also go and say, well, I want anything that is 192.168.0.0/24 or 124 into 172.20.0/24. It needs to be the same bit mask size.
Does it keep the last octet the same?
That depends on if you say keep hostpart.
Ah, cool.
If you don't want that, you can also go into the randomize hostpart, and then it will just randomize it, but still the randomization will be kept in the database, so every replacement will stay the same for the same appearance. What you then can do is, well, if there's no match, neither on the single IP address nor the subnet ranges, you can still randomize the rest. And there's a couple of options like including multicast, APIPA, or documentation addresses. Yes, there is a documentation range for IPv4 also, not only IPv6. APIPA is the automatic private IP addressing thing where you get 169.254, which is very, very anonymous because everybody could have it anywhere, so why sanitize it? And it could be a problem. I mean, if you see 169.254 IP in a capture file, that could be a problem. So if you don't want to, well, remove the problem from the trace, well, by default it will stay. You know? So you need to actively check this to randomize that one as well. And the one I added for specifically the ask.wireshark.org questions forum, I don't know if you've seen it or if somebody showed it to you. There's this page ask.wireshark.org where you can ask questions. Let's go there, just in case you haven't seen it. Yeah, but I think maybe my internet isn't working. Let's see. Oh, it seems like it's working. So this is a forum where you can ask questions about Wireshark, about network analysis, and there's people like me answering questions all the time. And very often people tell me, like, or tell us, like, we can't give you the capture file because it's sensitive information. So the most backlinking thing to Tracewrangling.com is right now the ask page, because we keep telling people like sanitize the place. Okay? The problem with that is they just randomize everything, and that is why I put this in here. which means if you have a source IP address or an original IP address that is like in a private range, like 192.168 or 172 or 10 dot something, it will randomize it but into another private range so that you know it was a private one. Yeah? Most people don't even change any of the settings, so that way we know this was private or this was public. You could also choose like, no, I want to randomize it on the full range, or don't even randomize it because it's private anyway. So I don't need to change it. Yeah? You can do this, but I went for the most sensitive one where I think, well, it will be randomized, so it's not the same again, but it will stay, it will have the attribute of being a private IP address. Okay, so I'm trying to make this as simple as I can, but as helpful as possible for the analysts, of course. Because I'm an analyst and I don't want to give you people like that are randomized like crazy where you can tell nothing about what was happening in the original one. Yeah.
So, Ted, this question, can you tell, is there a signature if someone has run this program?
Yeah.
Can you tell that it's been done?
I can, because Tracewrangling will write a file comment into the file header and say, this has been sanitized by Tracewrangling version something. You can, of course, remove it, but most people don't. So, usually you see if somebody's sending a sanitized trace, that is having a comment in the file.
But if someone has removed
That you can't, but yeah, but that's on purpose because I want people to be able to hide their tracks completely if they choose to. So I'm not putting anything hidden in there. Like I know we all know the hidden GIFs thingies that are used to track us. I hate those. So I'm not going to do this to my program. And it will do whatever you want it to. If you don't want the notification, I will probably even add an option to remove it or not write it to the file. Okay? So there's no point in making it trackable. Sometimes it's nice to know. And it's the first thing I do when I get a trace to look. It hasn't been sanitized. Because sometimes it's really broken. And then I ask myself, okay, is it broken because of the sanitization or because it was broken before? And in each and every time I asked that the person, he told me or she told me, no, it was like this before, so Tracewrangling didn't do anything wrong. So I'm always happy to hear that, which is fine. Okay, so by the way, this is IPv4, IPv6 and everything. You can have IP addresses in many layers. And for example, you won't see ARP here. There's no ARP replacement thing because ARP consists of IP addresses and MAC addresses. So you always have something like an IP address mapped to a MAC address. So these settings will simply be applied to any layer that has an IP address. Any MAC address change will be applied to anything that has a MAC address. And I'm currently working on sanitizing beacon frames for Wi-Fi. So you can then replace the MAC address and the beacon frames and the SSIDs if you want to. But that will take some time because Wi-Fi is kind of tricky to parse and rewrite. Okay, all the other things, I mean, IPv6 is quite the same. I changed a couple of things in IPv6. I don't know who's using IPv6 already, except Jeff, and he's not listening. You do a couple of you? Okay. IPv6 is really complicated to sanitize because there's so many dependencies between the IP addresses. There's no ARP anymore. So if you're using IPv6, ARP is nothing you will see. Instead you get ICMP-v6, and ICMP-v6 is using some funny things like solicited multicast addresses. And if you're sanitizing an IP address, you also need to sanitize the solicited multicast address that is used to find it. And that needs to be consistent with each other. And you also need to sanitize the MAC address it is based on so that they match. So if you're sanitizing an IPv6 address, it's really complicated because you need to know exactly what you're doing. And that is the thing where I think no sanitization tool right now can do the same as this one. Because I thought it was a simple change to get that fixed, and it took me 2 days of my weekend basically to get it fixed when it was broken. So I wrote a blog post about it if you want to see my little rant about it. Okay, so the other things probably, I mean, TCP is not even enabled by default because changing TCP ports is something that you rarely need to do because it breaks protocol detection in Wireshark. So if you want to, you can change the protocol ports, but usually it's not very helpful. So it's not enabled by default. The only thing that is enabled by default here still is the HTTP before, and it will just sanitize FQDNs. Yeah, and it will replace them with placeholders. Right now I have no way to replace them with specific things, because again, FQDNs are really hard to sanitize. Think of this, I have a domain that is called www.packetfoo.com, and I have a blog that is called blog.packetfoo.com. If I sanitize packetfoo.com, I need to keep it the same for both IP addresses, so the last part needs to stay the same for the originals. So you need to keep track of how the tree is built of the FQDN, and you need to replace them consistently. You can't just replace them by anything. So it's really complicated to do this, and I didn't have time. Okay? So basically that is what the sanitization thing does. You can just run this, and we should get a capture file in the background that is called HTTP sample anon. And you should see a 172 IP address in there now. This is the replaced address. And since I unchecked all the remove payload things, it keeps the HTTP stuff in here. So this would expose like my user agent and which URL I went on. And if I don't want that, well, just go in Tracewrangling, edit the task, tell it to remove unknown payloads, and maybe you can do the replacement with pattern thing, just for the fun of it. Run again. There's no reload button yet in this review sharp version, but it will be. So if I open a new randomized one, now there should be no HTTP anymore, as you can see here. Which makes it harder to read, of course, because now we don't know what is happening here, of course. But there's a clean cut after TCP, and you can see that the packets are different sizes, but it will always cut at the right spot. Okay, so that was the main function that it could always do. Now for something else, let's see if I can find the really funny stacked one, because that is an interesting one. I need to find my presentations because I forgot to copy it over. So that's an open one. Just a second. This one. This is fun. Oh, this is especially funny. So, it's become correct. Can you see how many layers it has? Yeah, I'll zoom in for you. So what we have is Ethernet, MPLS, Ethernet, IP, UDP, GPRS, IP, TCP. That is one of the longest packets I've seen so far. And I got that from a guy who said, well, Tracewrangling is great, but you cannot edit this because I couldn't edit MPLS. Now I can. So if you want, what the guy just basically wanted was like, can you remove everything except the last two layers plus the Ethernet in the middle? That should stay in there. So he wants Ethernet, IP, TCP. Everything else needs to go. And what you can't do is just cut away the bytes in between, because you need to readjust the insert types, the port numbers. It's a complicated process because there's a reason why Wireshark knows how to decode this, and the receiver too, because there's ether types in there. So, for example, if I take this Ethernet layer, you will see here that the ether type is MPS labeled switch packet. I cannot just put the IP behind it, because then MPLS decoder will kick in and try to decode IP as MPLS. So I need to change that to whatever follows. And there could be a lot of things following here, and actually it was hard to do this because of the Ethernet following the MPLS. I don't know if you've ever seen that. Who has seen MPLS before? A couple of you? Have you ever seen Ethernet over MPLS? Because usually you have IPv4 or IPv6 over MPLS. Not this guy, he had Ethernet over MPLS, and I didn't even know that it's possible. And, well, if you take a look at the MPLS shim here, as it's called, Can you tell me how Wireshark knows that after this MPLS layer, Ethernet will follow? Can you tell? If you can, tell me, because I can't. There's nothing in this telling me that the next thing will be Ethernet. And that is normal. Because with MPLS, the routers know what is supposed to be following a specific ship, and the packet doesn't. So I had to build some kind of heuristic, and what I did is actually this. And that's the same that is Wireshark doing now, because they had the same problem. When I see MPLS, I'm looking at the first byte of the next payload, and of that, the first nibble. If it's 4, it's IPv4, if it's 6, it's IPv6. If it's not, I jump into 14 or 13 bytes into the packet to check the ether type. If the ether type is something that I recognize, like IPv4, IPv6, ARP, reverse ARP, and VLAN, then I assume this is Ethernet over MPLS. And these are the kind of tricks that you have to do if there's no info in the layers. So, enough of this. Let's try to get it down to something that you can use. So, I will save this to my desktop to make it easier to get there. MPLS stuff. And then you use again Tracewrangling. Put it in there. Add an edit task. And on the edit task, you can go to the removal thing and tell it to please remove the GPTU header and the MPLS ships. If you're able to, it will remove everything that looks like remotely like an MPLS ship and the GPTU header. So, and here's the setting already where you can tell Tracewrangling, add a comment in the file that it was modified. Because this is not sanitization, so it's less security sensitive, so I chose to basically, well, it's kind of mixed up. I should have done that in the other one before. Anyway, so.
What if you don't have those headers? Would it just skip those parts?
If you don't have those, it will skip them, yes.
Okay.
I want to remove the task. Okay, now we're running the edit task on this. And we get a new file.
So there's not a is there a progress bar on the edits?
I think edit doesn't yet, but I'm going to add them. The problem with Tracewrangling is that the GUI code, like showing you fancy stuff, is taking ages to do. And I hate that. So I try to do the cool stuff where I'm fumbling around with packets. But every once in a while I have to do GUI stuff, and well, the GUI features are not always like up to speed, so it takes a while.
Just assume it's still new.
Yeah, could happen. So this is the result, as you can see. This is what was the MPLS thing before. Now we only have the last Ethernet layer, the last IP layer, the last transmission layer, and now you can push this into any tool you want, because this should be good. Okay, so this is basically the editing thing. If you edit something, it means removing layers and stuff like this, and not like editing packets directly. It will not edit packet content, except if it needs to rearrange structures and adjust data types and stuff like this. And you can daisy chain whatever you want in the editing thing. Okay, so. Oh, I can use that one for another feature. If I have the MPLS stuff for PCAP there's a file date, 23rd of June, 2 minutes ago, because I copied to my desktop. I don't know about you, but I like my file timestamps to be from the time where the capture was taken. Because very often someone is asking me, like, can you take a look at the capture from that day? And now I would have to open the file to see what the file timestamp is of the first frame, to see if it was from that day. And that's something I don't like, so what I added to Tracewrangling is you can go on the file and say, set the file timestamp to match the first frame in the file or the last, depending on if you wanted to have the file timestamp when it was closed or opened. So let's say I do first frame, because this is only still open. Of course, it needs to be closed first. Yeah, custom B. Custom B. Good. Now this should have modified and set to May 18th now. Yeah, so I think if I take a look in the Explorer window, it should show May 18th. Yeah, here. You can see. Now it's May 18th, which is the timestamp from the first packet in the file, so you know when it was taken. Okay? You can do more complicated stuff than this. You could also choose to rename the file and go in there and say, well, I want it to be renamed in a certain pattern. There are placeholders that you can put in there. And timestamp is one of them. Actually, what I did here is I chose a default pattern that is exactly the same as dumpcap does. So Wireshark will recognize renamed files as file sets. Then we can check if it works, because this is something I haven't tried so far. I wrote the code, but I didn't really demo it yet. I have a file set here that is called baseline 1 to 8. So I add them. Okay, so what Tracewrangling is doing whenever you add a file is it is scanning the file for all conversation, all IP addresses, everything it can find in the file. I did that already for the 7 at the bottom, but not for the first, just to be able to show it to you. So I tell it to scan it now. And you can see here it goes through the file and records what IP addresses, conversations it finds. Which is what I took it from when I did the sanitization thing. You saw the lookup table with all the IP addresses. That was because Tracewrangling already knew what was in the file by scanning. So now all of them are scanned. And to add them, that is really quick because the results are written to a database. So if I add them again, you will see that it goes really fast. It doesn't have to scan them again. Boom, done. Got all the meta information about all the conversation, all endpoints, everything from the database. It's really quick. So now I could go in here and say, well, I want to rename them like this. And done. So now you have a capture file set that is exactly named like Wireshark would do this when capturing. So you can use file sets and open them one by one in Wireshark. Yeah, so if you need to rename your files with the timestamp in the file name, it will read the first packet again, or the last, whatever you choose. Put the timestamp in the file name, and you have your file name with the timestamp in there. In case somebody copies it and the file timestamp gets messed up again. Yeah, so this is something I needed. Okay, so while we have them in there, let's do something fun. We have a tool here that is called Communication Details. And this is the table that I talked to you about. We have 13,658 TCP conversations in this file set. This is everything in all files. It's basically like conversation and endpoint statistics in Wireshark, but over all the files currently in the file list. And if you remove a file, it will recalculate. If you add a file and it's scanned already, it will be added. If it's not scanned, it will be scanned. Okay? So the fun thing here is, I mean, you've probably seen all this before. It gives you address A, address B, port A, port B. This is for TCP. Packets from A to B. But remember, over all files, not just one. All of them. And then we have the initial RTT as a column. So you can see right away which conversation seems to have some kind of problem setting up, like this one, with 261 milliseconds for initial handshake. That is pretty slow. Yeah? So sometimes I'm using this to, I have to do it by sorting to find the slow setups. Yeah? So now I know these are the slow ones that take a long time to even get the handshake done for the TCP session. Then, I'm not sure if I can show it on that screen because the screen is not really big. It doesn't allow me to resize for some reason. That is bad. I don't know what does that. Should give me a scroll bar because there's more columns to the right. This screen only has 1,000 pixels, so the font is actually wider than that. But I can't show you right now because it's off the screen for some reason. But what I can show you is if you are looking at this and saying, well, it's nice that you tell me that the IRTT is so high, well, can we check it? And yes, you can, just double click it. And you will see at the bottom of the thing here, there's an extraction message. And as soon as it's done, it should start whatever analyzer is configured. It doesn't right now. Does it? No, it's this one. This came up. And here we should have, again, I have a scroll box, but it's not fun. But we have the time here. So you can double click anything in the TCP list, it will extract it. It doesn't matter if it spans files or if it's in one file and then in the third, and the fifth, and the ninth. It will gather all the packets, put them together, write them to disk, and open Wireshark for you. Yeah, so you can extract anything that is in the list. So choose another one. Let's say this one. Maybe this time we... There it is, extract it, and take a look at it. Yeah, so you can use this to really quickly extract single flows from everything in the list and take a look. Yeah. The bad problem right now is that there is a column to the right that you can't see right now. That column is really important because it will tell you this is a SYN reset, this is a SYN egg, and then it works. Or this is a conversation that is only one-sided. Tracewrangling can tell that you only got packets going from one IP to the other, but nothing coming back. It will tell you this is a one-sided communication, which is kind of important if you're looking at traces and you're like, okay, I don't have the full conversation, it's only half of it. So that is the conversation statistics, and I use that all the time to work through large amounts of capture files because it's a full view over everything. You can also go in here and mark multiple of them and then say, well, extract them to a single file where the single file has all the conversations in there. We could also say, no, I want one file per row. If you do that, you get in a dialog where you again can configure how the file name should look like. And it shows the TCP flow scheme for the file. But you can insert additional things like a counter or something, a timestamp, whatever you want. Yeah? So if I do that and click OK, I get a new directory on my desktop, I think, because in the done. Close it, minimize it, traces, file set, I think it was. Now I have a new directory that's called extract. And in there are the three links and the lines that I selected with the naming, giving me the IP addresses and everything. Yeah, so extracting stuff from large sets of files is really easy with this. Just select them, export them down. I have 20 minutes left, good, because I have more to show you. Unless you're bored. Anybody bored? Yeah. Good, so let's remove those. Let's remove this one. Yeah. Cool. Fresh. It happens. So what else can we do? We can merge stuff, but I'm going to show you something more important. Do you know snort? Yeah? Okay, snort is like an IDS, intrusion detection system. You can use it to scan network traffic for malicious patterns, and that is something that you do in security quite often to check if there's something bad going on in the network, like attack patterns, scans, and whatnot. So here are a couple of captures that contain attacks. those attacks are actually on my own infrastructure. So this is taken in front of my own servers. So this is real data. This is live, or it was live at the time of the capture. It's really the database again. And I have here a so-called alert.ids. So this is what Storm gives me if it's scanning the PCAP files. It will tell me I found something like an ET scan SSH brute force. So everything that it detects, every malicious activity that is found will be put by Snort into this file. So what you need to do is run Snort over a set of trace files with a signature file, and it will tell you which signatures it found where. Like you can see, there's IP addresses in there, in that row here. Zoom is sometimes problematic. Like this is a socket that was found on. Up here is what it found. It says it's a fake putty version. That is something that is quite common. Sometimes it also complains about IPv6 tunneling, like stuff encapsulated in other stuff. And now my task in my normal job is often to verify if those are actual correct hits or if it's a false positive, because very often those are false positives. So what I used to do is open all the files in Wireshark and filter on the specific conversation with the IP address port, and it took forever to filter on this, and I had to open sometimes hundreds of trace files for a couple of hundred hits. So I was spending like days filtering stuff and then writing scripts to do it for me, and it's really no fun. So what I do here now is the following thing. I add a extraction task, and now I can go and say import from file, use the alert file, and if I do that, there's a couple of options we don't need to look at right now. It will import all the hits that it found and build filters from it. So this is an automatic process. It will just take the alert file, create filters from everything it finds in there for each single hit. We will have one filter, and it will also know what the hit was for. So there's a label for a filter. So the filter knows I'm filtering on that conversation because this was found. Okay, but you could put anything into the filter label if you want to. What's the filter label good for? You can go to the output page and insert the filter label in the file name. So now, when it's writing my new files, the first thing in the file name will be the signature of the hit that Snort did. So now, oh, this is an SHA scan, or this is a 64 timer or something. Okay? You can leave it out if you want to, but this is quite nice. And the other thing it will do, there's a metadata enrichment thing. So it knows at which sequence number the hit was when it was scanning the packets. So it will do a file comment or a frame comment into the file that this was the exact frame where the signature matched. So if I open it, I can tell, well, this is Y, and Y is the hit. So let's try it. It'll take a while. Let's run it. So here's the progress thing. So sometimes I do this if I have time. So now we could take a look at the directory, and you will see that in there's now an extracted directory, and the files have appeared. And I have a file name that is exactly the signature name, plus IP addresses, ports, and everything. So now when it's done, it's still working on it, okay? Wait for a while, but maybe the first one are already completely written. Let's try, let's use this one, the Mozilla one. Just double click them, of course opening Wireshark, if it's not too busy to write new files. Come on. Okay, we'll give it a couple of seconds to finish. I mean, I gave it a set of 5 files that is a total of about a gigabyte or something. So it's quite some work. Okay, open this. And you will see that it is the single conversation, and you will notice that the head command is in a green color. That is because I assigned a color profile that tells me there's a comment in that frame. Okay, it shows to be green. So if I take a look at it, you can see here's a packet comment that will tell me this is the exact packet where that pattern matched, like the fake Mozilla user agent. And that's the one you can see here. That is the user agent that is not really a normal. Yeah, usually it has like stuff like .NET something and I don't know. So this is like a signature where Snort thinks, this could be somebody trying to do something. And you don't see head commands that much in a normal HTTP operation anyway. Yeah, so now I can just open them real quick, and this is now why I asked the Wireshark developers to put in drag and drop for me. Because I don't want to open the Wireshark each and every time for a new file. What I do now is I have more than one monitor, of course, like you do. And I have the list on one and the Wireshark on the other, and I just keep dragging them over quickly, looking at them like, this is nothing, this is nothing, this is nothing, this is nothing, okay, done. It's like 5 times faster than doing it with open, okay, or starting up Wireshark each and every time. It's too slow. Huh?
What did that get at?
In Qt Shark,
Yeah.
like last week, Evan, yeah, it's starting, so yeah, probably last week. In the old one, it was in there like for ages. And I use it all the time. Okay. Hansan learned something new, so he's happy. And, well, then I reached my goal. Oh, yeah. Okay, so this is what you can do, but this is something that is not limited to Snort, of course. What you can also do is, if I, well, let's do a new extraction task. And remove all the files. That's the last one I'm going to demo now. Let's say I have a file here that is called XP2 Websites, which is one of our trainings that we did. And let's say I want to have all packets where there's a cookie in there. HTTP cookie, right? So http.cookie. Zoom in. There. It's like this, that is the filter name. Apply. So I got all the packets that have cookies. The problem now is I want to have the full conversations, not just the one packet where the cookie appeared. So how do I do that? Well, I could click on every single one, filter for the conversation, look at it, go back to the HTTP cookie, get the list again, check the next one, and I told you I'm too lazy for that. So what I do now is I export this one. What's happening here? My screen is suddenly. Export specified packets. I just export the packets with a cookie in there. Cookies.pkfd. I can close the file now. I add the file to Tracewrangling. It scans it. Then I do another extraction task. I add the file again, but not an alert file like before. This time I'm going to use a capture file. It's on my desktop somewhere. Where is it? It should be on my desktop. What is it in traces? Ah, there it is. pkfd.pk. Doesn't matter. Okay. So it builds filters for each packet it finds in the cookies file. And now we can run that thing again. Now we'll get, again, extracted files. This time, one file per HTTP session that had a cookie. At least I hope it does. The correct one, maybe. There it is. Yeah, so basically, if you need to have a specific thing, and you want all packets that have this specific thing, you can export it to a new file, like an indicator file, and then use that to extract all the flows that had all the indicators, because you need to see the full flows. And just throw them into Tracewrangling, it will export them. You can choose the file naming as you want to, and you could even edit the labels to something that you want to be part of the file name. Yeah, so that is what I do with Tracewrangling, and basically in the end it doesn't replace Wireshark at all. Wireshark is basically the one file, let's take a look at the close detail thing, but Tracewrangling is the one tool that I use if I have like a ton of capture files, and sometimes I have half a terabyte of stuff, and I can't open them all in Wireshark one after the other, so I just throw them in here, and then I use the conversation statistic or an extraction task or whatever, to reduce the amount of stuff that I need to look at to manageable amounts. And then Wireshark is used to actually look at everything. So this is what it's good for. You can use it to anonymize, or to extract, or edit, or rename. You name it. If you have anything else you need, let me know. I could probably put it in there if I find the spare time, which is quite rare. But that's about it. So download it, play with it, and let me know if it crashes. The funny thing about anonymization is, if it crashes during anonymization, and I ask for a PCAP file, everybody's like, I wanted to anonymize it to give it away, so... But sometimes they still give it to me, like, please don't share it. Yeah, okay. And actually, I had a funny email conversation with the guy. He was saying, well, I saw your Tracewrangling on SharkFest' 2012. And he said, well, he's going to build a web-based service for anonymization of PCAPs. And I said, well, wait a minute. So you're having people send you the originals and you give them the anonymized versions? Yeah. Okay. You know what the problem is? It's not that they don't trust you, they probably won't. But what will happen if somebody breaks into your web service, steals all the originals, and your clients get into trouble? Have you talked to legal about this? And he was like, I think I should not do this. Okay, thank you. Any questions? Yeah.
Do you have any vision for respecting
What file?
include similar features like what you did with maybe this whole file like you're talking about?
So looking for slot signatures. Do you mean looking for slot signatures myself?
Right. I mean, we added this small analyzing
Well, what I can do is, if you have another list of something that identifies packets, I can build it in and extract stuff for you. What I'm not going to do is to do the smart signature matching, because that is what smart is for. Yeah, they do it perfectly. There's no reason for me to do it.
what I was asking was doing something similar. So we can Syslog file.
Syslog, okay. So basically the question is, can I use other indicator files to pull flows from the whole set? Yes, I can, as soon as I know what your format is. If you give me a CSV and I know which the fields are, I could put it in there, no problem. Sure. Other questions? Yeah, good.
What do we go to configure to not replace capture application with sanitized by Tracewrangling?
Right now you need a hex editor. Right now you need a hex editor and change the Tracewrangling binary. But I can add basically I can add a field in the options where you can choose to either not include the comment or edit it if you want to. No problem. Anyone else? If not, find me at the reef. I'm at the reef from 2 p.m. I think, to 4. And I will I've already put up my challenge, which is a really hot one. So if you want to try it, it's a real world thing I solved in basically about 2 hours. If you want to give it a try, it's a real thing. It's anonymized, of course, and it's big, so it's much bigger than the ones that you have over there.
What was the problem you're trying to do?
The
Why did you
problem
go
was-
with the trace route?
In that trace routes from the challenge, basically the customer was telling me that they have done a stress test for a new infrastructure, and at some point the server that gets requests stops answering, and they didn't know why.
The server stopped responding.
It will not respond anymore. And they wanted to know what happens. I mean, is it a server problem? Do the packets get lost in between somewhere? It's really complicated because you have so many communication in there. So if you want to try your real skills and not just small ones on the small packet challenges, come and see me. I have USB sticks with a lot of data for you. Okay, thank you, and see you next time.